Hello everyone, welcome back to the tutorials on Ansys Workbench. Today we will solve one problem on tapered bar. This is the problem statement. For the tapered bar shown in the figure, determine the displacement, stress and reaction in the bar. So this is the tapered bar shown in the sketch. So one end of the tapered bar is having an area of 1000 mm square. The other end of the tapered bar is having an area of 500 mm square. Given Young's modulus as 200 GPa, length of the tapered bar is 375 mm, and the one end of a tapered bar is fixed, the other end having a load of 1000 Newton. So to solve this problem by using Ansys Workbench, first I need to create this tapered bar. To do that, first I need to calculate the diameter by using the area given. So we have a formula for area of circle 1/4 of pi d square. Substitute for area and find the diameters d1 and d2. So here d1 I will get it as 35.68 mm. So the next highest value is 36 mm. d2 as 25.32 mm. So next highest value is 26 mm. So I will consider d1 as 36 mm, d2 as 26 mm. So now let us solve this problem by using Ansys Workbench. So just double click and rename this as tapered bar. So right click on engineering data, go for edit. So by default software will be assigned to a structural steel. You just check the Young's modulus, so it is 211 Pascal. So this is what given in the problem. So if you are not creating any new material, if you are going with the same material like structural steel, by default it will be assigned to your model. So next right click on geometry, go for new design modeler geometry, click on XY plane, look at face, change the units to millimeter. Now go for sketching. You can select polyline directly. Here I am going to create the symmetry of this tapered bar, later choosing the axis, and I am going to revolve this to create a tapered bar. So first I will start from here. So finally you can right click and you can closed end. So it will close the end and go for dimension. First dimension, second dimension and the third dimension. So now go for editing the values. Now first I will assign the value for V1. V1 is nothing but half of D1. As I said, we are just creating the symmetry of it. So half of this 36 divided by 2. So this is 18. Next V2, 26 divided by 2, 13. Next, length of this tapered bar is 375 mm. So this H3 is 375 mm. Okay, you can scroll out. You can see the entire symmetry of a tapered bar. Now I am going to revolve this geometry. So select revolve. So it is asking for geometry. By default geometry has been selected. Apply. Next axis, click on axis. Select this as an axis. Apply. So now rotation angle is 360 degree. Click on generate. So you can see the tapered bar over here. So now go back to your project workbench, double click on model. Your model has successfully imported. So now I need to define the loads. So as like previous problem, we don't want to assign any materials over here because it is a single tapered bar and it is made up of a single material, that is stainless steel. So directly go for meshing. So click on mesh, directly go for meshing. Here if you want any particular type of element size, you can specify that element size over here, or else software will calculate the elemental size directly. You can right click and you can click on generate mesh. So mesh has been generated successfully. Next go for static structural, right click. I want to insert fixed support, click on the face. So click on this face, apply. Next I want to apply load over here. So right click on static structural, insert force, click on this face, change this to components. So now you can see it is in the x direction. So in the x direction it is 1000 Newton. Okay, next click on solution. So geometry is not selected over here, so click on this geometry and apply. Okay, so it's done. Again solution, right click, insert. So deformation total. Next insert stress equivalent. If you want to find the reaction, right click on solution, insert, go for probe, and here you can see force reaction. So click on this force reaction and it is asking for end, so it is in the fixed support. Okay, so now you can right click on solution and click on solve. So your solution is ready. You just click on total deformation. So this is the minimum and this is the maximum deformation, and you can also play this animation. So this color band indicates the deformation from minimum to maximum, and you can also go for equivalent stress. This is minimum and this is the maximum, and the force reaction you can see at the fixed end, so its value is 1000 Newton. Okay, force reaction is minus 1000 Newton. So you can generate the report. So report has been generated for you, so you can print or you can share this report for further use. So that's all for today's session. Thank you. See you all in the next video.